Instead.
So, hi everyone, how are you doing? So, I'll start by presenting myself. My name is João Granado. I'm a software engineer, as Marco said, at Farfetch. And today I'm here to talk about the right amount of sugar. So, what is the right amount of sugar? And the answer is the right amount of sugar is trying to find, in our own context as software developers, is trying to find the balance between power and order. When I say power, power is the amount of control we have over a tool. And this means when you say, for example, a powerful tool, usually this means that this tool has some features and you have really a great amount of control over it. But power, at the same time, has some downsides, and you have a huge surface area of possible bugs, and your users won't understand how these features integrate with each other. So sometimes we need to limit power to create order. And what is this like? What does that really mean? How can I get right amount of sugar? Like, are you expecting me to answer this question? Like, what is this balance? Like, are you expecting me to show you some code, or are you expecting me to show code examples? Only? Okay. Sorry, I won't. I won't show you any examples, no fancy JavaScript stuff. I know this talk might be a disappointment for you, but today I'm here to talk about something that I really care. I really think about this, like, not just as a developer, but in my personal life, in everything I try to do. So let me tell you a little story about why I'm here today. I'm here because I was invited to talk about monads. Yeah, monads. And when these guys invited me to talk about monads, the thing was, and I started to think about this, why are monads so difficult to understand? But almost immediately, I thought about another question, and I changed it to, why are some abstractions so difficult to understand? Obviously, there are many reasons in functional programming, obviously, and I won't talk about questionable naming conventions. But the main reason, in my opinion, with all these abstractions, they are too generic, and they have so overly generic concepts that it is completely difficult to find a concrete use case for them. When I say concrete use cases, are things that aren't that immediately useful. For example, when we talking about monads, for example, they are so a broad concept. You need to understand lots of little concepts to understand them, and other abstractions like Babel or Webpack or SLint, they're not useful. They don't build applications. They are just a mean to build an application. Okay, so with too many options, we're left to chaos because these tools, people struggle every day. Like the JavaScript fatigue is caused by by lots of configuration, initial bootstrap. So this bring me today, and I really feel this like in my daily basis and my day job at Farfetch. For example, my team, our job is to create tools, and our latest projects involve creating tools that wrap Webpack, SLint, and other tools like Babel, etc. And wrap these, creating toolboxes so other developers at Farfetch know can install them and just simply run like this command core scripts lint, core scripts build, and they don't need to know anything about what's being done in the background. And in every planning we have in our team, we usually make this assumption. We can make assumptions. For example, at Farfetch, we are lots of developers, so you can make assumptions. Assumptions like, for example, it is okay for you if you're building some tool to open source tool to say, okay, I don't support Windows, I don't support Unix. We can do that at Farfetch, for example, because we don't know what my team, our teammate is using, like the operating system, what is their background, if they are like experts in JavaScript or they are coming, like newly coming from like a .NET background to JavaScript. So we need to have this kind of care and make no assumptions. So we just build for our reality. So with this, I personally made some guidelines. They are completely opinionated. This is my own opinion, not my team's opinion. But I try to follow these guidelines. And the first one, and in my opinion, it is the most important one, is make it good and then make it better. Okay? What this means is, like, for example, prettier. In the beginning, if who knows what prettier is? Okay. Prettier in the beginning is like a tool to prettify your code. In the beginning, they don't have any configuration because the main concern was to make this tool be like really good, like prettify your code like in a way that no other tool ever done. So and if you apply this principle to every single thing you do as software developers, you're good. And usually, when when I am in some meeting or some planning, like discussing the next feature or the next step we gonna do in our next step in our deadline. Sorry, milestone. Sorry. I usually use this metaphor that I read like some years ago. I don't remember where. It was in a blog post, but this particular blog post was like really amazing. I don't know the name. I just call it the French fries paradox, and which is you're like starving. Not starving, you are like in the middle of the night, like with that craving for a cheeseburger. And it is like amazing, like the cheese and the pickles and the patty. And then you go straight to McDonald's. And suddenly you are like, oh my God, French fries will be amazing. But then you have this kind of nostalgia thinking about a menu with a dessert. So you ask for ice cream. But wait, you are so lucky that at McDonald's, in that specific day, they are making a promotion for more €2. You can get like not this, but this times 2. So you eat it all, you go home, and you're like, oh my God, it was so good. But then, wait, you're sick. You are completely full because you have more than you really could handle. You just ask for like you just want like a cheeseburger, and you had the fries and times 2, and so the conclusion is, and passing this to software development, don't try to cover every single use case ever. Like you can do this. You just try to make what you have like really good, like working perfectly. If you try to do everything at once and try to you have 2 consequences. You have no product at all, and then you won't have something that is fully functional. And you have bugs, a huge surface of possible errors, lots of issues. Your user will suffer because they will need to know everything about your tool, everything about your possible options, and how they interact with each other. But even if you try to follow this rule strictly, there are always problems because initially you probably don't know how the product will actually work for sure. You can't cover every use case, so you need to make choices. So there will be things that will pass. So this brings me to this. Don't be afraid of killing our babies. uh, don't be afraid of killing our babies, okay? They're just babies. No, just kidding. What this means is you don't need to be afraid of removing options, removing stuff that initially will look like really necessary, because something is only necessary until you make it completely unnecessary. And of course, yeah. But it is true that you can't be afraid of removing it. You just need to be careful. So when you do this, we pass to the next point, which is build bridges and not walls. What I mean with this is like, if you remove something and it is a breaking change, you need to think that the user was actually using that feature. So you need to create deprecation warnings, for example, to create a migration path, because deprecation warnings offer migration path actually. It is better instead of removing and your user try to update to the next version, they will hit a wall, obviously, because you know, like, nobody, it is one of the assumptions we always make, is like nobody reads the README. Nobody. It's like you can't assume like that anyone will read the actual documentation or the changelog. They will just hit a wall when something is broken on a new update, and they'll just leave the tool, and they will assume that nothing works. So for the sake of user experience and developer experience, instead of just removing the feature and wait for the user to hit a wall, just build a bridge, build a path, guide them, and say that they need to update that feature to this new feature, and then everything will be all right in next version. Okay, so choose names wisely. Names are, you know, like one of the most important things in computer science. Science is one of, at the same time, is one of the most difficult things, because important things are usually difficult to do, because names and a good name provides context. In a concrete case of, for example, monads and functional programming and these data structures. For example, what is a functor? What is a monad? Like this name, what does that mean? If you go to the dictionary, it doesn't have any correlation to the actual meaning of this data structure. But instead, if I say like a functor is a mappable. Okay, I don't know how this actually works, but a mappable probably is something I can map over. Okay, I have a context. And a monad. A monad, one of the million definitions, is not the end of functor, is like a pointed functor which can be flattened. It's like, what the fuck? But if I say like, instead of monad, combinable. Combinable as a context, I don't know how this works, but the first time I read it, a combinable, for example, is something that can be combined, so with other combinables or with other things. So if I say a combinable is a pointed blah blah, mappable, which can be flattened. Or a combinable is a subset of a mappable. So it's something that can be mapped over, but can be combined. So we have a context, and variables like ABC, foo, bar, that doesn't mean nothing. And you can actually see these kind of things in production code. It is okay to have this in internal stuff, but the higher you go in your API, like the surface, and choosing like names. I remember this example, for example, in Angular, they called transclusion. Where is it was like a thing, a core concept of Angular, transclusion. You need to go deep in the computer science vocabulary to understand what transclusion was. Instead, if they call it templating or including something into a template, it will be better probably. So build for humans, not for machines. This applies to names, to meaningful error messages. For example, if you remove something, deprecation warnings are really important. The machine won't care about that you remove it. Like, okay, I'm prepared for this. If you just keep some step because some property is not valid for some kind of environment, the machine will just keep it, but people will add this option, and this option won't work, it'll be ignored. But if you warn people like, this option is not valid here, please remove it. You'll be doing a favor to yourselves and to the code base. You won't have dead code there. You will have like clean and meaningful stuff in your applications. And this is the end of this talk. I just want to have a conclusion with a title of a book I read years ago called The Laws of Simplicity. And I really tried to follow these laws. But one of them, and this one, I used them like 80% of the year, is the simplicity is about subtracting the obvious and adding the meaningful. If you apply this to your job or to other fields, design, etc., you will have actually meaningful stuff and not obnoxious things floating in your code that nobody cares about, and people really suffer with this. Like, just I think it is this. Thank you.